we have to look around corners. Right? We cannot judge what AI can do on the basis of what it's doing today. You have to plan for the fact that it's going to get better, especially because in the last 18 months at least,
yes,
the pace of innovation is so high that if you plan your products around what AI is capable of today, you're going to miss the boat because you're going to solve the wrong problems, or your solutions will become obsolete when the next version makes a leapfrog, right? So one thing that I've come to see is we try not to obsess over what AI is bad at. We try to obsess over how we can harness it and then bet on the fact that it's going to get better.
Welcome, Collective Nation, to another installment of the GenAICollective podcast, Collective Intelligence. Today, in the studio, we have Prasanna from Machinify, CEO of the company. I'd love to just start off with you telling us about your prior work experiences, what led you to those roles, what specific insight you gained from those experiences, and how that led to your current work.
Nice to be on. Thank you for inviting me. My career started at Stanford, so I was doing my PhD in computer science, and I was working on distributed systems and database technology. And life had taken a different turn. I had been a professor, but I met my co-founder of my first company, Guru, who really had this compelling value proposition. He wanted to see how this was a moment where the internet was just starting to take off, and bandwidth was starting to become cheaper, and you could contemplate doing things over the internet that really wasn't possible before, like delivering video. And so we had this crazy idea that we could deliver movies over the internet back when it didn't feel possible. And I had a bunch of experience in figuring out how to get things to work with distributed systems and how to do it on the cheap, because this is still in an era where delivering a gigabyte cost $1 back in 2005. And of course, as Blockbuster in those days, maybe before your time, typically it's $3 out of 4 would go to a studio. You had about $1 left over, which didn't really work for internet economics of that time.
Right.
So we started out trying to solve that problem. We invented some peer-to-peer technology to figure out how to drive bandwidth costs down. And we built a company around that, which we sold to Walmart in 2010. And by then, of course, problem had moved up the stack. The interesting thing with I guess it's really a pattern in computer science. Every year problems tend to percolate up the stack as each layer of the stack gets solved. So by the time we sold the company, bandwidth was about 3 cents a gigabyte. So it had dropped by 30x in 5 years, right? So we kind of lived through that era where you had 2 orders of magnitude change in the cost of delivering bytes over the internet. So the problems no longer were about how do you deliver bits cheaply. It was really at a different layer where you had to solve distribution. You had to solve for how do you get into the living room. Even that started to become a solved problem. You had to solve for user experience and retention, and starting to use machine learning to figure out how do you get people to come back and all those kinds of problems. So that was a really interesting journey, because I would say every year at that company we were solving a problem at a different layer of the stack. And that sort of got me, to go back to my core passions. Like we had solved the difficult technical problems of, delivering data over the internet. And it seemed clear that the next wave of interesting problems were going to be around a different phenomenon that was just starting to take off. If you think about the 2000s, it was an era of transitioning a lot of workflows to be digitally native, which means you had a lot of trail of data being collected about every process. And it had gotten cheap enough to collect and store all this data. Storage costs have also been dropping quite dramatically, exponentially, really, during that period.
Right.
And every company now was sitting on piles of data. They were paying for storing all this data, but nobody really knew how to use it to unlock value in the business. Of course, the prime example of someone who did know was Google, right? Like you would say the first killer use case of machine learning, which moved market caps, was that Google figured out how to make people click on ads. Right? How do you learn continuously what are the right ads to click on? So it was one of the first examples of a continuous feedback loop driven by machine learning, where every time a user did or didn't click on something, the system learned to make a different decision the next time. And so what I got interested in was trying to see how do you build that kind of self-driving enterprise where you could take any problem that exists in an enterprise, where decisions are being made, usually by rules-based software or by people, and figure out how do you let a machine take it over and build a feedback loop so it can just make smarter and smarter decisions as time passes. And that was the genesis of Machinify.
Okay, so can you break down the cost curve? Because I think that's a brilliant breakdown of how cost curves can impact innovation and what becomes the problem of the day. So I mean, maybe with Machinify, what is that cost curve that you might be writing and benefiting from that you definitely benefited from maybe in your prior work, or is there a different set of problems that are occurring, a different set of innovations that are occurring?
Yeah, I think with Machinify, I mean, of course, the cost curve has gotten down to the point where most processes are digital and they're
Hmm.
leaving a trail behind, and the costs are negligible to collect all this data. So now I think the next layer of problem is really around how do you monetize the data, or how do you use it most effectively to create business value.
Hmm.
Now, of course, you have other kinds of cost curves, right? GPUs, for example, are a very scarce resource today, and there's a whole lot of problems we're solving today around how do you make best use, get the most bang for the buck for every dollar you spend on a GPU resource. My guess is that yes, it's a critical problem to solve today. My guess is also that this will be a useless problem to solve in 5 years, right? That's just the way the world goes.
Right, right, of
In the
course.
sense that things get cheaper and problems that were essential to your survival this year will become irrelevant in a few years, right?
Right.
There's a planned obsolescence around a lot of this invention. I think the foundational problems that will tend to survive are around how do you even build algorithms or systems, design systems that can learn to become smarter and smarter over time. I think those are fairly foundational problems that I think will stand the test of time.
Well, I mean, I think Jeff Bezos has a quote that you shouldn't ask. People will ask him what will change in 5 years, and he has a quote that says, instead of asking that, ask what won't change in 5 years. So for Amazon, that means customers will never want will never want higher prices. They'll never want their products, slower. Um, and whenever innovation he needs to leverage to do that, he will. So if he needs to build out a logistics network, he'll build that out. And if it means that they are more so capital intensive now, it doesn't matter. What matters is delivering for customers. So I think what you are hitting on is a similar, I think, analysis that other founders or researchers should think about, which is thinking about, okay, this problem, what parts of the problem won't change and what parts will, and then how do I solve for that in the interim? So maybe with that, we can kind of dive into your team's work at Machinify. I mean, the healthcare market, especially with AI, is something that I found fascinating for a number of years, and there are very few companies have cracked the code in the healthcare market the way you guys have done. So to rattle off some stats, $200 billion medical in medical claims reviewed annually, 52 million lives impacted by Machinify. You're working with 4 of the top 10 largest payers, which is just astonishing because it has been a very hard market to crack for startups without a large corporate partnership backing them. So curious to just if your reaction to the success you've had. Are there core principles that you focus in on to kind of crack the case there?
Yeah, I would say I don't really know. Like, there isn't a secret sauce to it. Um, I think the way we looked at it, we were trying to figure out self-driving enterprises. We knew that there were a ton of processes that where suboptimal decisions were being made, and we knew that we could do better. But we were a company trying to do AI. Really, none of us had any background in healthcare, so we didn't know anything about what these processes were and what is the right way to make the decision. And we didn't have any data. Like, all the interesting data is really in the hands of the largest insurance companies in the country. I mean, especially if you're looking for longitudinal data to understand what happens to a patient over time, that data tends to live with the largest payers in the country. So we just said we had to go find a way to work with them. And I was fortunate to work with a co-founder who can move mountains when it comes to getting us in the door. And then we had to earn our credibility and trust one customer at a time. um, get a chance to work with someone, get them to believe in our crazy ideas. I'm sure that they did not, right? It took us a long time to get past the hump of us being able to articulate something that made sense to our customers, and for them to believe that it's worth a shot. And so we started. We found a sufficient overlap of use cases where there was relatively quick proof points we could deliver to see what can AI do for you. It didn't help that most companies have dabbled in AI and most of them have failed, right?
Right.
Most projects that they've tried have failed because these things are hard. it's not always obvious to people what problems are usefully solved with AI and what problems are not. So, we had to overcome all of those things, and we had a few false starts along the way. But finally, we got to a point where we could solve some problems. Well, we were able to take claims and figure out how to pay them correctly. And then that one thing led to another. So from there, we could start predicting what a future claim for a member might look like. And we could use that to predict diagnoses that are likely to be right or wrong. And we were then able to use that to start to predict things around what is the right treatment to offer a patient. So that each one of those allowed us to expand to more and more interesting use cases that we could go solve on top of the same foundation.
So there's two pieces to a successful sort of healthcare company, which is the first is the go-to-market, so how you've structured getting into the door, and then there's the actual technology process. Now, I think one of the key things that an AI-related company would have that a traditional software company wouldn't have is that a traditional software company can just prove we can store your data, take a chance on us, run a pilot period. Whereas with an AI company, they have to say, we could do it, but you just need to give us your data first. How do you, let's first break down that first step of how do you solve that catch-22, because it's something that I've thought about a lot. I'm curious to hear your thoughts there.
Yeah, it's definitely a bootstrapping problem. Every one of the customers we landed, the big customers, we had to go prove that the technology worked on their data. It wasn't enough for us to be able to say, look, we have this magic tool that will do smart things on your data. You had to prove that it actually did smart things on their data. And so essentially you're running pilots to prove that the technology works and there was value. The other challenge we had was we were really interested in solving what you would consider to be core problems. Like fundamentally, there are two kinds of products you can sell to an enterprise. Most commonly, you're selling a piece of software or a service for something that isn't core to the enterprise. Like an enterprise buys a word processor, or they buy a messaging system, but it's never a thing they would build on their own, right? It's a no-brainer. And so the price points are structured that way, and the level of risk that the enterprise takes to try the technology is also much lower because, if this word processor doesn't work, you throw it out and buy another one.
Yes.
Right? But when it comes to AI solutions that are going to help make your core transaction, the thing that's at the heart of your enterprise, run faster, you're not going to be very experimental in your thinking about what to try and what not to try. I mean, the bar for deciding to adopt something is much higher because it's a core problem.
Right.
And so it is inevitable that, the buyer is going to have extremely high standards and a very stringent process for determining what they would deem to be an acceptable decision to make. And so you just have to build the company in recognition of that. Thankfully, I generally tend to consider myself a first principles thinker. I think a lot of the standard patterns that would apply to a classical enterprise SaaS startup did not apply to us, or I believed it didn't. So we didn't run the company the same way. For example, we raised a Series A in 2018 and we haven't raised it since. And that was a reflection of the nature of the go-to-market and the nature of what is the right way to sell a core product to large enterprises.
Okay, we'll get to the your funding philosophy later on, definitely. But and so to drill down into this idea of the pilots. Okay, so there's the core software versus the what I would call auxiliary software. So I was just listening to a talk. ServiceNow, I think COO did a talk at Sequoia talking about the significance of CIOs in the sales process. Whereas, with the rise of Twilio, that idea of the importance of the CIO was inverted, where now the engineer was the most important piece of the selling process, and having already customers within the organization and then taking that customer base and then selling to CIO versus going directly to the CIO for some of these auxiliary products. Curious, like how your team saw the kind of key customer persona between the CIO or someone else in the organization. How did you identify that person and kind of work with them at first?
Yeah, to date, our focus has been on the line of business owner. One of the things at Machinify that we decided early on we wanted to focus on is we want to prove value in a quantifiable way to the business owner. And especially in an industry like healthcare, which is relatively conservative with good reason, you're not talking to customers who are risk-seeking, right? They're risk-averse. And so you have to have compelling value that is tangible for them to try something new. And so we said we had to prove a lot of financial value immediately. And the way you do that is by selling to the business owner and by showing them actual impact to their top line or bottom line. And so that's been our go-to-market motion ever since. Now, as we get, more of a foothold where we have established products and established value that the market recognizes, we are starting to have broader discussions around how do you build a platform, right? How do you do something enterprise-wide? But that's been our graduation path. It's always been go to the business owner and say, hey, how do we help you deliver tens of millions of dollars of value, over, on an annual basis, or hundreds of millions, as the case may be.
Okay, so let's dive into that, the platform approach that you've just touched upon. So you have Machinify Auth, Machinify Audit, and Machinify Pay. Maybe let's break down what each is, the core problem. So what is a pain point, the customer persona, and the workflow, and then I can actually back it up some of the kind of key problems that you're facing with some stats. Just kind of diving into the research on my own. I think there's significant markets in each of these product segments, but maybe just give a high level overview for each of these.
So I'll give you the common pattern across them first, and then we can dive into each problem. If you think about any healthcare business process, and it's probably true across additional industries as well, but certainly in the world of healthcare, you have a pile of policies or rules that govern how decisions should be made. And depending on the problem, if it's auth, we're talking about medical policies that determine when is the right treatment for each condition. Right? Or if you're talking about audit, you're talking about how do you code a diagnosis or a procedure correctly on a claim to represent what actually happened in a hospital. Or with payments, you're reading contracts and figuring out how much should you pay for this and what's the member responsibility and what's the insurance responsibility. Whatever. So all of these ultimately are about taking a big pile of rules and making sure you can enforce them. Now, the challenge tends to be that you're talking about a million pages of rules that are changing daily. It's an N-square problem. Every health plan and every provider have different arrangements. You've got CMS, you've got regulations, laws. Federal law contains rules about how to pay claims if you do it. So all of these need to be digested somehow. That's one problem. And the second is that enforcing them is really hard sometimes because the data you operate on is unstructured. You have medical records. Claims are more structured, but data tends to be very error prone. You don't really know what it says. You don't know whether to believe what it says. So you have to figure out how to solve these two problems. And each one of our products is really an instantiation of that problem for a different point in the healthcare transaction flow. Ultimately, our vision is to build a system that runs in the cloud that digests all these rules and can enforce them across any point in the life cycle. So to take concrete examples now, so what is pay? It's about understanding all the payment policies that exist, all the benefits plans that exist, understanding all the contracts that exist between providers and payers, in order to figure out how do you take a claim, how do you make sure it's coded correctly, fix all the coding errors, and then compute the correct price to pay, and determine allocation of responsibility across parties. So that's the product. Why do people care? Because there are hundreds of billions of dollars of payments that are wrong every year. It's like a huge percentage of the overall spend. And today, in fact, the hundreds of billions that are corrected after the fact. So this is just the known errors. Never mind the unknown errors that still lurk out there that nobody even knows about. Right? And so there is clearly a well-defined problem. There is a market that tries to solve it. It's not exactly using the world's most advanced technology to solve it. And it's limited by what can be done in that mode.
Right.
And so problem we set out to solve was, can we just reimagine it from the ground up? Can we just instead think of this as essentially a large language model coding problem? You have all these rules written in English. Can you just turn them into software? By doing a giant, think of it as a GitHub Copilot for healthcare rules, right? Can you just digest them all and turn it into a piece of software that can then just run and figure out the right thing? And in fact, in the world of pay, I believe that's possible because it's actually pretty deterministic once you know all the rules. It's knowing the rules that's really hard. And sometimes, of course, the data is messy and so you have to guess at what the data really should have been, right? There is uncertainty around data. But there isn't an intrinsic uncertainty anywhere else. The difficulty is in knowing all the rules. But it's hard enough that the problem's been unsolved for tens of years. And so that's the tack we've taken to try and attack this problem. And it's leading us to some really interesting places. We're starting to, for the first time, try to solve problems in a way where the solutions are permanent. Historically, in the world of payment, it's always a series of leaks that spring from the adjudication process, and then people are working on patches to fix each leak. And then you accumulate over time tens of thousands of these patches, but it's a never-ending journey, right? Every day there is a new leak, you figure out a new patch, and then there is no way to reason holistically about, what all these patches cumulatively do. We're saying, okay, let's go to the, basics. Let's go find all the rules and let's translate the rules directly into software and see what it can do.
Okay, so this is something, so you mentioned your background in systems. My background is actually in distributed deep learning, so kind of the next generation of applying some of the distributed systems concepts to large language model training and inference. One of the things that I was a bit frustrated with the application of deep learning was that you could see real world applications in consumer, because consumers, the number one value proposition is the creativity and generation, whereas in sort of more knowledge intensive domains such as healthcare, you would rather a system that is less intelligent but just never makes mistakes than a system that's wildly intelligent but on the margins has a 0.005% chance of making a mistake. Right. And so that was very frustrating for me because I could not control my model completely. I could create, I could fine tune to the nth degree and train for hours and train across all the GPUs I wanted. But at the end of the day, if I didn't have a 0% chance of error, I can't deploy. So maybe for the audience's sake, and this is actually very, very useful, you have to kind of two tools in your toolkit, rule-based systems that we've honed in since the 1990s and probably earlier than that, versus deep learning systems, particularly transformer-based architectures that recently come out that are wildly intelligent, but also have some chance of errors. Where do you think of applying these two tools to the problem set in healthcare?
Yeah, that's a great question. I think we should think of this as a system building problem as opposed to making a binary choice between rules and AI. Mm-hmm. Fundamentally, I think what's amazing about large language models is all the ways in which they differ from your traditional software or traditional machine learning, right? Where traditionally software is about doing something reliably and repeatably. Mm-hmm. And so it's an extremely reliable component, but it's not necessarily creative. It can't solve problems it hasn't seen before. Now with large language models, I kind of think of it as very human-like, even though we know it doesn't under the hood work exactly like a human, but yes, it's learning to mimic a human. So what it's really doing is it's a highly unreliable component. It will surprise you with its ability to understand novel questions. It's highly unintuitive that it understands it for someone who's written software, but it's completely flaky, right? You just cannot make any promises about its output. So now how do you build a reliable system or a reliable process out of these unreliable components? I think that's where the art of design comes in. There are a few things that work in our favor. So one conscious choice we made was that we wanted to start our journey in healthcare on the administrative side rather than on the medical clinical practice side. We just didn't feel like clinical practice was the right starting use case for experimenting with the use of AI. Like the stakes are way higher. Yes. And you had to find lower stakes problems to solve for it. Mm-hmm. And then even within administration, you can be very thoughtful about where you do and don't apply it or the manner in which you apply it. Like, should you trust AI always? No. But if you can use it to make certain decisions that are safe, you can go on. For example, we work on authorizations. So one of the big challenges in the country is that getting an approval to perform a medical procedure is a cumbersome process. It can take 2 weeks to get an approval, even though the overall approval rate is like, depending on the case, anywhere from 70 to 99%. It's still a very cumbersome process to get to this thing that mostly should be approved. So could you automate approvals without ever automating denials, right? Because if you're going to deny care, that's not a thing you should really trust AI to do today, right? Wow. I wouldn't. But how about you solve one side of the problem that's much more tractable, right? And, I think like an engineer, so I want to find milestones along the way that are tractable, achievable, and as a startup, of course, generate revenue, right? Before, instead of having some kind of, approach where you need to cross a threshold before it becomes useful. Like the self-driving car problem requires you to cross a very high bar before you can deploy it. As a startup with not funded like Weibo is, that's not necessarily the path that leads us to success. So those are approaches that you can take. Now, the other huge element that we focus on is the human in the loop. Um, we try to write, just like with Asimov's 3 laws, we try to write our 3 laws of how we should use AI to be effective in our domains. And the first law that we came up with was you should really use LLMs as on problems where it may be difficult to come up with a solution, but it's very cheap to verify. It kind of reminds me of the P equals NP question from computer science.
Yes.
Right? Like, the open problem of the last 50 years, there are a whole class of problems. We know that it's very cheap for machines to verify the answer, but we don't know if it's possible to, in polynomial time, compute the answer from scratch, right? And I think the best use cases for LLMs are situations where a human can verify the answer really fast, especially if you can take control of the user experience and present the right information by post-processing what it does. But it may not be very easy for a human to come up with the answer. And that's where a lot of the business value gets created at this stage of maturity. Now, maybe everything I say is wrong when GPT 5 or 6 comes out, whenever it does, right? But given the current state of maturity of LLMs, that's where I see a lot of the value being created. And so if you can build solutions that tap into the creativity of LLMs, come up with proposed answers, and you establish a means for a human to validate the answer in seconds, we can still cut a 45-minute process for a human to a 2-minute process.
Okay, so what you're saying is there's still a chance for deep learning systems. It's just that we may need a human in the loop. The human may take on the role of a manager or editor to those systems, such that the creative process, the generative process, may be time-consuming, whereas the editing process is really where the human has expertise, can differentiate itself, and we can actually. So that's one piece, and another piece that you mentioned was this idea of choosing your problems carefully. You don't necessarily have to go after all problems with AI, but there are certain problems where the risk of a negative outcome is lower, and so there's no problem with using AI in those situations because it speeds up processes. At your example, you're most likely going to get approved, so AI is a perfect use case there. So now we have that insight. Maybe we can do another deep dive into Machinify. So you mentioned Machinify Pay. I'm not sure. Maybe you're sort of integrating audit and auth into that. But if you wanted to dive a little bit deeper into the other components of Machinify platform.
Yeah. So payment at the end of the day is about taking this huge pile of rules. It's really deterministic, but it's just complicated, ambiguous. You need to turn it into software. It's almost like an offline use of LLMs. That's another killer way in which to use LLMs today in a safe way. Because yes, you may need to verify the generated code, but that's a one-time cost. Once you verify it, it's just like any other software, right? You bypassed all the risks around deep learning. Now, with audit, the problem gets harder and more interesting. Increasingly, if you think about how healthcare is paid for in the US, there's a shift from what I'll call the fee-for-service era to the Moneyball era, right? Like increasingly you want to pay people based on the value added, right? Historically, you would pay based on, I oversimplify to say we deliver this many aspirins and band-aids and there's a fee for each and you add them up and that's what you get paid, right? But that's no longer the case, and it's not been the case actually for a fairly decent amount of time when it comes to more complex kinds of healthcare. If you have an inpatient stay, increasingly most reimbursement methods would pay the hospital as a function of what is actually wrong with the patient and what is the state of the patient when they arrive, what is the state of the patient when they left, right? And you measure the delta in terms of patient state, right? And then you pay based on that. You don't really pay based on the services rendered. You pay based on outcomes.
Yes, right? Outcomes-based care.
And so that's really cool. It aligns incentives. It incents a hospital to figure out efficient ways to get the patient to be better. Right? It's a fairly clever system. The challenge is you need to now measure the states of these patients and you need to validate those states. Turns out there isn't really a national standard for most diagnoses, right? Like if you said the patient has pneumonia, how do you know the patient has pneumonia? Does everybody agree on a universal standard for when the patient has pneumonia? And the answer is no.
Right.
So there are, of course, different entities have different points of view, and part of the challenge in trying to solve this problem is that we need to first create that standard. We need to create ideally you'd want the standard to be based on objective measures versus subjective statements. Like The standard can be the physician stated the patient had pneumonia and it was documented. So you could have a standard at the level of documentation, but ideally you would have a standard at the level of objective measures. Oh, we did this test, we did this culture, the culture said X, there was growth, whatever, right? Like there is an actual underlying biology here that you would like to build a standard around and then establish this is what it means for a patient to have condition X. And that's what makes the labeling of the condition useful for other purposes as well, right? If you want to do statistical studies on the patients with pneumonia develop this other condition 30 days later, you'd like to have a consistent definition for what does it mean for the patient to have that. And so that's the next level of problem we're working on, or we've been working on, which is try to come up with objective measures for patient state and figure out how machines can actually read the medical record and validate that patient state or establish characteristics of the patient that were not documented. And depending on the reimbursement methods at play, all of these matter. In some situations, it can be more adversarial where you declare the patient is sicker, you get paid more money, and the payer's incentives are to ensure that documentation is correct. There are other models where, in fact, everybody is aligned on trying to get to the accurate representation of what the condition of the patient is, so that you can figure out the right things to do. Either way, what the technology need is of being able to read medical records at scale and truly figure out what's going on with these patients, like what is their state at different points in time.
So almost as the fuel to the outcomes-based healthcare system is verifying patient outcomes, right?
Correct.
Wow. I mean, because there has been so much talk about the shift to outcomes-based care. The key question people have been asking is, how do you verify that? I guess maybe to dive a little bit deeper into the space. So how do you kind of verify or improve that out to potential customer that you're able to do this?
Yeah, I would say there are two dimensions we typically look at anytime we're looking to solve a problem like this. So one is around automation, right? How much more efficiently can you get to the same answer? But the other is around accuracy and consistency. You talked about needing to be 99.5 or whatever level accurate. The reality is that my measures say humans are only about 80% accurate at most jobs in healthcare. And in some areas where the standards are less well defined, their agreement rate is actually much lower than that. So you can ask two different experts, what do you think about the situation? And the fraction of the time they agree is not as high as you would think, right? And this tells you there isn't a consensus on what is, how do you get to the answer? The algorithm is unclear, or there is just, randomness in the process. And so those are the two variables we work on. The first thing we work on is, okay, in order to automate something, you need to know what's right. Otherwise, you don't have a framework to even think about accuracy. And our lesson has been that we should never take for granted that people agree on what's right. We need to go establish that standard of what is right. And that's a precursor to automation. And what we've found is that, in fact, there's a huge value in just making all those conversations happen. Two people in the company may secretly disagree about how to decide something, but until you force the conversation to happen and you write down the policy, it's not clear that there is that disagreement. So we do that. And then we measure did consistency increase, but decisions more accurate in a sense, right? And typically we will find accuracy increases. And furthermore, we can then measure, okay, how much less time does it take to get to the same decision? That's easy to measure. I would say we think of this as levels of autonomy. So right now, I'll say mostly we are at level 2 where we have co-pilots that help a human in the loop make a decision faster. This year, we've just started making progress. I think we're getting close to level 3 where you can skip human review or have a much faster human validation of a full review done by AI for these complex audit problems where you have to go read 500-page medical records and come up with answer typically between 500 and 700 distinct questions, and then use those to decide what is and isn't true. So we're starting to approach the point where that can be fully automated for some of the more common cases. I mean, obviously, it's a really exotic situation. I mean, the universe of questions that you need to learn to answer to solve every problem is in the hundreds of thousands. So we haven't solved all of those problems yet. But for the short head of most frequently disputed questions, we're starting to get there in terms of ethics.
That is just unbelievable because, so one is, there's literature, a lot of literature using AI, rules-based systems in healthcare. So now we've kind of touched a little bit about the Machinify platform. I'm just itching to ask about kind of the go-to-market because there's a lot of literature and a lot of the problems are solved, but it's frustrating. It feels like you're kind of banging your head against the wall when it comes to healthcare industry because of the risk aversion that can happen within institutions. Maybe you can let's do a sort of a game here. I am someone working in healthcare. I'm evaluating Machinify. How am I thinking about? We talked about ROI. We talked about some of these sort of pilot systems. But how do I really know that Machinify is the real deal? How does Machinify prove that and talk about your go to market in those kind of including sort of payment errors, including reimbursements?
Yeah. I think with payment it tends to be simpler. We can usually, if we have to prove ourselves in a pilot, we can usually tell a payer, hey, give me all the claims you paid over the last few years. And you've sifted through it with a fine-tooth comb. You've thrown 75 vendors at it to find all errors. It's theoretically error-free. And we'll turn around and show you a whole lot of errors costing you tens of millions of dollars, right? And so that would be the process that we would run if we were doing a pilot. Now, as we've gotten more mature and we now have national payers for whom we've proven value, we can simply point to, hey, look at this national payer and here's what we've solved for them. We've eliminated a majority of the errors they had in their claims from 3 years ago. And that's an example of, proof point through reference. Right? So that's paid. When it comes to audit, you have to worry more about safety because it's not just about, hey, we can do something better, but it had better not be risky and it better not create chances of providers getting upset because you told them they did something wrong when they didn't. Right, so we have to prove both safety and efficiency, and there we rely on studies that show how much time savings exist and how much accuracy increases are possible. One of the things that works in our favor is that the process as it runs today is a very abrasive process between provider and payer. It contributes to a lot of friction because fundamentally what happens is that a provider submits a claim and says, yeah, patient had these conditions. At admission, we had these conditions on discharge. But the receiver of the claim, which is the payer, has no way to independently verify this. That's in the medical record. You have to go get the medical record and read it before you know. And so historically, you can think of it as a random process, right? It's a random audit where they might select some subset of claims. Sure, it's rules-based, but in effect, it feels random because the odds that any one claim you pick is wrong is pretty low. So to a provider, it just feels like useless work they have to do. They have to now submit extra information just to prove that they did everything right.
Right.
So it's an abrasive process and everybody recognizes it and there is a cost in the system due to it, right? Therefore, rates go higher because the provider has to pay for all the work being done to supply the documentation, whatever. And unfortunately, these things, a good fraction of the time they're transmitted by fax, right? This is not an automated process by any means. So when we come in, part of our value proposition is we now have models that can predict what a patient is likely or not likely to have. We can look at a claim and we can already estimate the probability that every single code on it is right or wrong. And therefore, we can be very precise in selecting which claims to spend energy on so that a provider is not upgraded. Like, to the extent we are going to them and asking for more information, there's a significant probability that they did something incorrectly. And so, while yes, it is still work for them, it's work where there is feedback to them on, hey, you could have done your job differently and then you wouldn't have had this audit. So that's been helpful. So it creates an immediate value that is very tangible. You can see they call this hit rate. What fraction of claims you pick turn out to be wrong. We can show a meaningful increase in hit rate well beyond what's standard in the industry. Then when it comes to human productivity, the measurements are further down in time. You have to deploy the software and get teams trained on it and so on. Increasingly, we're starting to offer that as a service where it's just simpler for many payers to let us own the liability of executing this correctly. To the extent we got it wrong, we bear the risk of dealing with the provider and correcting it. Which also, in instances, it allows us to go faster because we can learn from our mistakes much sooner. I think in most AI use cases, the critical point is how fast can you run the feedback?
Yes.
How quickly can you learn from your mistakes? So the further we simplify the process, the faster the product gets better.
And could you break down how AI is infused into your product, in terms of policy digestion, policy enforcement?
Yeah, so policy digestion we talked about.
Yep.
It's think of it as co-pilot for policy. I'm oversimplifying. In reality, there are different kinds of policy that need different forms of translation. You've got contracts, where you're really extracting all kinds of rules about how to pay things. You've got policy documents where you're extracting a very, very different set of rules. So you have to build systems that learn how to translate into different languages, if you will. The enforcement tends to come down to how do you interpret medical records. That's probably the biggest challenge. When it comes to claims are structured data. So it's, once you have the rules, you can apply the rules on claims. Mostly that's a matter of, executing deterministic logic. Because, when the government writes down rules for how you pay for things, there's no room for uncertainty or ambiguity, right? It has to be correct to the penny. So it's a matter of knowing the rules and then running them. But when it comes to medical records, clinical decision-making, validity of diagnoses, necessity of procedures, those tend to be much more nuanced and complicated. And effectively, it presumes that you understand medicine, right? That,
Exactly.
You've got it. You've been trained as a doctor. So because the rules are written for a doctor to understand, not for a layperson to understand.
Okay.
And so it's a process of learning how to answer those clinical questions. And of structuring those policies so that you can use those clinical questions to derive conclusions.
So, actually, you just touched upon a very critical aspect of deepboarding teams. So, let's focus on NLP as a subfield. You might have had a computer scientist, a linguistics person, a subject matter expert. Now, with the rise of deep learning, the kind of linguist and the computer scientist have kind of merged. You can train a model on sort of next word prediction, and even the in certain applications, the utility of needing a medical expert has in certain applications been less necessary as it was before, because before you might have been actually encoding rules as opposed to now it's a lot of encoding knowledge through next word prediction. Maybe you could talk about how do you structure teams to both utilize the expertise of a subject matter expert in healthcare who can understand some of these regulations, and then pairing that with an engineer who wants to develop quickly. They want to develop great software, and they may not want to interface. They just want to build their technology. They don't want to worry about anyone else.
This is, in fact, the number one problem to solve for any company trying to do AI for a vertical.
Yes.
I think success is almost entirely correlated with, can you actually understand the domain all the way down? And in healthcare, this is particularly challenging because the domain is hard to understand. Whether you're talking about administration or clinical, it takes years to master the domain. And I would say my lesson has been that it's difficult to get it done just by having an expert in each area sit together in a room. Yes, of course, you try that. But in fact, there is still a lot of difficulty in translating between those people, right? Because they all speak their own language, right? They have their argot that's defined by their job. And when they use the same words in English, the words don't mean the same thing to the other person.
It's a machine translation problem. You need another transformer between the engineer and the... Yeah.
I would say the secret to our success has been to hire for people who actually care a lot about mastering new things and to invest in actually learning. Like I would say any data scientist we hire has to commit to understanding healthcare administration fundamentally. Right? Go get certified as a coder, right? You have to have that level of understanding, because only then, I do believe that a lot of knowledge needs to be in one brain for you to connect the dots and figure out how to solve some of these problems. It's very difficult when the knowledge is permanently partitioned across brains, because human language is imperfect and unioning all of those things together is hard. So I would say that's the secret. We have to hire people who care passionately about crossing domain boundaries.
And this is something I've noticed as well in healthcare teams, AI healthcare teams is, for example, at Stanford Medicine, we were working on heart disease detection, and you couldn't, one of the inputs and features into the model that I built was responses to symptoms. But the issue is that some of these surveys to determine what was called rheumatic heart disease is that you don't know as an engineer, you don't know which questions are pertinent, which ones are actually are relevant to the model. And so just choosing your features into the model, you need a subject matter expert. So that is something I'd never, I'd really thought of. And then, developing conversational AI at Cure AI is you have the whole slew of similar problems. The knowledge base need some conversation with healthcare experts. And so I think healthcare, financial services, these are spaces that are very unique in that the way you develop the model from day one can be impacted by interfacing with healthcare expert. So maybe that kind of leads us to the second component of just talking us through some of the most significant technological hurdles that you face and how you can overcome those challenges. And that'll be very useful for some of the listeners who are also building their own vertical focused systems.
Yeah, I would say, one thing we talked about is knowing what problem to pick that is worth solving with AI or, AI adjacent software. That can be one of the earliest things that we saw when we worked with customers, and this was maybe 5-6 years ago, was everybody thought of AI as a black box. It can solve anything, right? But people didn't really have a built-in decision tree in their heads of these problems are uniquely addressable by AI and these problems are not. So that's level one. So we can make a lot of mistakes by choosing the wrong problems to attack. The second thing is that it's easy to get stuck in local optima. And what I mean by that is, for example, if I take the payment problem, one way to address the payment problem somewhat effectively with machine learning is you can say, take a large pile of claims that have been generated. Some of them were paid right the first time, some of them were not. So you could train a classifier to say, predict whether a claim will be paid right the first time. And it will find a ton of patterns. It will tell you these patterns of claims, they tend to have more mistakes than these. You can use it to rank order work for people, whatever, right? There's a bunch of value to be created with some kind of ranking model. And in fact, that's where we started, because when we started, we knew nothing about healthcare. So to us, everything looked like data that we could train a model on. But the problem is, that's not a path to 100% accuracy. It's not a path to a fully automated system. Yes, you will discover patterns. You will discover that these kinds of claims are, likely to be wrong, and these kinds of claims are likely to be right. But it's never going to get to 100% accuracy. And in fact, we know that machine learning models generally don't tend to get to 100% accuracy.
Right. Even the best models will get to 95, get to 90. Yeah.
It's difficult. But in fact, there is a completely different approach to solving the same problem with 100% accuracy through a completely different set of learning models, right? Which is to start from the rules and use large language models to translate the rules. And so it's easy to get stuck in a local maximum by saying, let me build a classifier on some labeled data, when in fact, the path to salvation lies elsewhere. So that's a second class of traps that we have fallen into and we've emerged out of, right? So then when it gets to execution, the third trap that I think is easy for companies to fall into is to think of a model as being the solution as opposed to being a component of a solution. Especially because if you're using LLMs, because they're unreliable components, I think it's really critical that we think of building a holistic product that solves a business problem and start downwards from there, as opposed to starting from what can a model do for me. I think there are two related lessons we've learned here. One is that if you want to automate a business process, you have to build an application with a human in the loop to start. And essentially you instrument that application and you hire the most expert human possible to do the job, and you instrument what they do, right? And then from there, you can determine what are the steps in the job, what are all the pieces to the puzzle, how do you isolate each piece, how do you get detailed feedback about each one of those pieces, and you automate one piece at a time. And then as you automate it, you have to build a user experience around it, which is great, which causes the user who's doing the job to actually collaborate in teaching you how the job should be done versus the way you thought it should be done. So our lesson has been, we must build this human in the loop UX. It's as much a user experience problem as it is a machine learning problem. And designing those to create the right incentives for the human to provide the right kind of feedback is critical to learning the thing that you really need to learn. There's lots of label data being generated in the industry, but the reality that we've seen is most of the labels are either bad or unsuitable to the problem that you actually want to solve.
Yes.
And so we've invested a lot of energy in saying, no, the software must come first and it must generate the right kinds of labels So then you can have humans produce the right kinds of labels for the ML to take over. So that is lesson number 2. Again, learned the hard way. We initially thought, hey, customer, give me label data, I'll do something. The labels weren't that helpful. And then I would say lesson number 3 is it's kind of Gall's law, right? So it's a software engineering thing of all complex systems are built out of simple subsystems. And it's easy to think, oh, we can go, maybe I'll be wrong, right? Again, who can predict what the future holds when it comes to deep learning and what turns out to be differentiable and optimizable with gradient descent, right? But my experience has been there are boundaries across problems that you cannot just solve by throwing end-to-end deep learning. You have to break the problem into pieces, solve each sub-problem. At least that's how my brain works. And independently establish the validity of each sub-module. Then you can compose the sub-modules to do really complicated things. And so even if you were to use an LLM, you have a lot of practical challenges. I think we had an hour yesterday where whatever our large language model, GPT, whatever, decided to misbehave, right? I think I've heard rumors on Twitter that sometimes it gets into a mode where it's lazy and just tells you to do your own work.
Yes.
It's doing the work for you.
Right.
So how do you build reliable, robust systems when the components you build upon are flaky? You have to have cascading fallbacks. And then if you can isolate the errors to a submodule, then it can be contained and you can find a fix within the submodule and the rest of the system can still function. But when you have complex end-to-end systems that are built as a monolith, it's very difficult to create robustness.
So, and what you're saying, I think, is the prevailing notion, even amongst the most advanced deep learning researchers from DeepMind, this idea that we won't just have one monolith language model that knows all, sees all. There will be specialist language models that will be integrated into your workflow. And I think that's our thesis at Stanford DSB as well, is that you'll have specialized, very accurate, focused LMs, and we can then debug a system just in the way you would debug a software system with unit testing and etc. So, is there any sort of best practice you learned through that? In terms of what you think of RAG, in terms of batch processing, some of those lessons there.
Yeah, I would say, well, you brought up 2 things that are actually quite interesting. RAG is a good example. The lesson for me there was don't trust Twitter. It's easy to fall into a trap of someone saying, yeah, I tried this, whatever, by encoder or cross encoder, and it's amazing. It's on the top of the leaderboard. Let's just throw it in and it'll do something. Right? And the surprising part is we found it did something. It actually looked like it worked. But the challenge is to go from a demo to a production product. Like many of these things can get you to really interesting demos and fool you into thinking they work, but you never quite realize that at least they don't work optimally, right? So if you're pushing on that, one lesson we learned in RAG for the kinds of data we work with, which is faxed medical records quite often, like which we have to OCR, we have to do complicated pipelines on. Most of the off-the-shelf models aren't trained on that kind of data. It's, the distribution of sentences that we see, very different from distribution of sentences seen by the typical open source model. And so RAG semantic search turned out to be significantly worse than keyword search, for example, out of the box, right? And if we hadn't thought to test for that, we wouldn't have realized it, because of course everyone wants to tell you that the great new thing is great, and they'll try to never compare it to the best-in-class technology of 30 years ago, right? So thankfully, I still remember my lessons of using Lucene in the year 2000. And so it's surprisingly competitive in certain kinds of areas. And so I would say I've learned that search techniques ought to be respected.
Yes.
And we should not fall prey to, semantic search being the solution to everything. We also ended up learning a bunch of lessons about how you need to train your own models in order to embed things correctly for your domain, which turned out to be really critical for achieving correct sentence similarity. Batch processing, this is the other huge challenge that we have with LLMs, which is latency. There are a whole lot of use cases that you could solve in batch, which are difficult to solve in real time, because especially for us with human-in-the-loop apps, users don't want to wait. So we have to be really thoughtful about how we can push more and more things to batch, which is kind of counter to exciting things about let's do everything in real time. No, we actually think, no, if you can do it offline, that's better, because then I can try 7 different queries to solve a problem, and that gives me the time to iterate. If the first 3 queries fail, I can still try a fourth. But if it's a user-facing interaction where the user is pressing a button and you need to make something happen, you have to optimize for latency and you can't optimize for quality. And so being thoughtful about where you can shift things to batch is actually a good idea.
I mean, what you're saying is this is probably my favorite part of the episode, because I think the listeners have heard me rant about how you need to study the prior machine learning techniques, because I see too many papers where it's saying we've designed a system, a question answering system, you'll check the accuracy and it's worse than systems that were built 20 years ago. And so if you don't know, the job of a machine learning engineer is very different from a researcher. A researcher should be pushing the boundaries and the field and seeing what type of new architectures should be put in place. But I think an engineer, and this is why I love machine learning engineering, is because it's about being practical. What delivers the highest accuracy and the lowest latency? And if that means I need to go back to the 1990s and dig up a support vector machine system, I'll do that. I don't care. I just want something that is intelligent. So I love that idea. And the idea of batch processing is something I wholeheartedly agree with. I think, we saw, some of the Apache, Hadoop is another good example that really kickstarted the batch processing innovation. And I think what people might think now is, oh, that's old school. Now we're on to real-time systems like Confluent systems. And I think that there's a time and a place for everything. Sometimes, no matter what, real-time will be slower than batch, because with batch, you cache your results. It can be, you can deliver that at low latency and at lower cost. And so I wholeheartedly agree with your assessment. And the key question will be, when will RAG be a better use for your company? So I guess, maybe zooming out now, and we've dug into the go-to-market, the key technology challenges. Maybe a lot of our listeners are startup founders. They're looking for what their impact on the broader ecosystem. Maybe you could talk about Machinify's solution and what do you hope the impact on costs and the collective healthcare processes in the U.S. and how do you want to change that?
Yeah. If you look at US healthcare, I would say about 25% is considered to be waste. And we're talking about 25% of an extremely large number. Like, I think $4.5 trillion of annual expenditure, that's about 19% of GDP. And so a quarter of that is considered to be wasted. You can attribute it to 2 things. One is administrative overhead. It's like, I try to analogize it to swiping a credit card. When you swipe a credit card, the frictional cost is around 2% between what the issuing bank needs to make to underwrite the loan and what they charge the merchant. In healthcare, the frictional cost is somewhere around 10 to 15%. And that's a really, really large number on a big numerator. And so we think this is definitely ripe for transformation. What's been holding us back is language. Say rules are in English, enforcement requires reading English. And I feel like we are on the cusp of a significant transformation in how we can solve these problems, which hold the promise of taking a lot of the frictional cost out of the system. But that's step 1, right? I think what's truly exciting is then if the cost of doing something shrinks by 10x or 100x, what would you do with the technology that you don't even dream about doing today? Today, if you want to read a medical record, it's assumed that it'll cost $100. And so you try not to read medical records. It's a super expensive thing. I mean, maybe you have to read it if someone wants to get a $20,000 surgery, right? But you try not to read it because it's expensive. So how much information is locked up there that need not be if it costs, let's say, $1 or 50 cents to read a medical record? What would you do with all that knowledge that's unlocked? How would it transform how we can predict things about patients, how we can speed up learning about patterns in the data that may inform how you discover the next drug, whatever it is. So I think those are transformative use cases. I don't know what they are yet because I'm not a healthcare expert or I'm trying to become one, but I'm not one. But I do think that's where the lion's share of value will end up being over the long run.
Okay, and in terms of what do you think are the misconceptions that companies have about AI and healthcare? How do you address these? And I think that will be useful for people in other verticals, in financial services, in whatever you can heavily automate. Automotive is a great example. Just some of these industries have a lot of regulation, a lot of risk aversion. How do you kind of battle that?
I think if you're talking to or trying to transform an industry that has a history of regulation and safety first, I think you have to provide a framework for them to understand why safety is not sacrificed in the altar of AI. For example, with what we do, first thing we do is actually invest in even more quote unquote regulation, writing down even more rules, because you need to put guardrails around whatever you ask your AI to do. You need to define why a decision is made. It needs to be explainable. And so to do that, you need a framework for explaining, which is, well, here are the rules for when you declare that this patient should do this. And then, given those guardrails, you use AI to answer the atomic questions that feed into that policy. Right? So if a policy has, if you knew the answer to 100 questions, you could decide whether X should be done or not. That's still ultimately a human-driven policy decision. It's influenced by business goals. It's influenced by trade-offs between safety and speed, whatever it is. Humans want a say in what those rules are. But what AI has a role to play in is in helping you provide the atomic facts that feed into the decision. That's where we see the state of AI today. We don't want AI deciding whether a patient has a condition. We want AI determining a set of objective facts about a patient, on the basis of which policymakers can write a policy to declare when someone is deemed to have a condition or not. In this case, the policymaker is maybe a team of doctors reading the latest research to agree on a definition for the condition, right? So I think that framework allows for us to apply AI in places where there is high levels of risk or irreversibility associated with decisions. Nobody wants a black box to make those decisions.
Okay. And I guess we're kind of coming up on time, so I'll just kind of ask you the last final question that we always ask every guest, which is, what is the AI industry going to look like in 1 year from now? You could also talk about AI in healthcare, however you want to take that, and any parting insights, what you know to be true about the world right now and how that'll transform the world.
I don't know what it's going to look like 1 year from now, but maybe I can provide one insight that I think about, which is we have to look around corners, right? You cannot judge what AI can do on the basis of what it's doing today. You have to plan for the fact that it's going to get better, especially because in the last 18 months at least,
yes,
the pace of innovation is so high that if you plan your products around what AI is capable of today, you're going to miss the boat, because you're going to solve the wrong problems, or your solutions will become obsolete when the next version it makes a leapfrog, right? So one thing that I've come to see is we try not to obsess over what AI is bad at. We try to obsess over how we can harness it and then bet on the fact that it's going to get better. Of course, you need your safety nets to deal with the situations where it doesn't do what you want. But yeah, it's been a challenge because you're building atop something that's changing so rapidly.
And I think that's the history of Silicon Valley, which is whether it's the transistor or the CPU, constantly trying to see, we know that these things will get better, it will improve in performance, and building things for the next generation as opposed to the current generation. That's a problem that has plagued startup founders in the valley where we are now for decades, and I'm sure it'll be like that moving forward. So with that, everyone, that's our interview with Prasanna. Collective Nation, as we wrap up another episode, I want to express my gratitude to you, our curious and passionate listener. As we are always building this podcast with the GenAI Collective, please reach out with any feedback or suggestions. If you'd like to be a guest in the Collective Intelligence podcast, please reach out. Doing so will be in the show notes or podcast player. If you enjoyed this episode and would like to support the Collective Intelligence podcast, please leave a review or comment on your favorite podcast platform. Thank you for being a part of this journey. Keep questioning, keep exploring.